Welcome. My name is Bruce Webb. I appreciate you getting up this morning and coming to the first session. Just as a bit of context, I know a few people in the room, most I do not. So I've been in aviation like many people in this room, I'm certain, for my whole adult life. I've been flying helicopters for 36 years. I still fly helicopters. It's not my primary role anymore at Airbus. I've been with Airbus for 20 years. I was a chief pilot at Airbus for 16 of those years. I stepped down voluntarily. I stepped down as chief pilot 2 years ago, 2016, July of 16, to do this. So I'm very fortunate that I was able to convince Airbus to allow me to write a job description, which is essentially to do what I'm doing here today. So before I start on my presentation, I want to make a comment about what Carl said yesterday. And I don't say Carl because I know him. In fact, I do not know him. I introduced myself yesterday to him, but I will butcher his last name. So I hope he'll forgive me. But he asked us, he challenged us to think about, does safety start at the top or at the bottom or at the frontline employees? And of course, the answer is we all believe. I think we all would agree it begins with all of us, right? You can't have one without the other. And I agree with that. I think that's 100% correct. But I'm not certain that's our issue in our industry. It's does it stop? What stops safety? And I pose, just for contemplation, it stops at the top, not at the bottom. Think about it. If you have an employee, if you're an executive within an organization and you have employees that aren't on board with the safety program, right? They say, I refuse to do whatever it is that you're asking them. I just won't do it. Well, then you have an obligation as an executive within an organization to remove them from that position, right? If you have someone who refuses to use a checklist, I'm a pilot, and you say you must use a checklist, and I say I will not. What will you do with me? You have to, I can't work there. You can't allow that. But if the reverse is true, if I as a pilot say, I refuse to use a checklist, and management says, we don't really care that much, then safety stops. It takes both groups to start it, but one group can certainly stop it, and that's at the top. I fear that it takes the executives' constant vigilance to keep it moving forward. And I think CHC certainly has that reputation, but that's something we all have to strive for. Anyway, I digress. My presentation is on unintended consequences. And I believe that when we look at unintended consequences, most of us think it's a negative thing, right? If I take an action and there's a consequence and it was unintended, it must be a bad consequence. Sometimes it is. Those are the ones that get the publicity, right? Those are the ones that we speak about, that we're aware of. But that's not always the case. So, I find this, I try to make my presentations all about life and flying because I think it gives us perspective, right? And certainly you can't do this. You can't stomp on all the caterpillars and then wonder why there are no butterflies. And if you're in Texas and you have a little bit of time and you're willing to travel, drive down to Austin and San Marcos and San Antonio this time of year, and you will see hundreds of thousands of monarch butterflies going to Mexico this time of year. You can't drive your car or walk without striking them. There are just millions of them. Anyway, so I want to talk about some consequences. First, let's define it. So, of course, we know what a consequence is, right? And an unintended one is one that was not deliberate or intentional. So whether we have an operational procedure that we prescribe that a flight crew use or a maintenance action in a work card or a accounting procedure or principle. Sometimes there's a consequence that is not desirable, sometimes it is desirable. And it may be contrary to the planned one. So let's talk about some examples. Prohibition. So the 18th Amendment to the Constitution of the United States was ratified in January of 1919. January of 1919. In that year, on that month, we as a society chose to outlaw the manufacture, transportation, and sale of alcohol. It was not illegal to drink alcohol during Prohibition. It was not illegal to drink it. You just couldn't buy it. You couldn't transport it, and you couldn't make it. But you could get a prescription for it, by the by, much like medical marijuana today. You could get a prescription for alcohol during Prohibition. And that's why, too, when we think about prohibition, speakeasies and people consuming the alcohol, they weren't in danger of being arrested. You didn't arrest them. They were doing nothing illegal. The people selling it to you were the illegal people. Now, and you say, well, what's the unintended consequence of prohibition? Well, think about 20 years earlier than 1919. In 1899, a gentleman was born in New York City, and his name was Alfonso Capone. Al Capone, Scarface. Al Capone was born in New York in 1899, and when Prohibition was enacted, he moved to Chicago. He was a small-town thug. He was a small-time thug in New York City. He was a small-time mobster. But you have to realize or think about what was organized crime before Prohibition? What were they making their money doing? And it was primarily two things: prostitution, and gambling. That was what organized crime was involved in. But that's a pretty small market, really. But when the U.S. government outlawed the consumption or the sale of alcohol, holy mackerel, the mobsters saw a huge opportunity for growth. And they did. When Capone moved to Chicago, he started the largest crime syndicate ever known at the time. Ever known. So, unfortunately, you can't put the genie back in the bottle. After that occurred, right, after the organized crime took hold, we've had a problem with that, a big problem with organized crime since. Now, it's not so much alcohol anymore, right, because, of course, the 21st Amendment repealed the 18th Amendment. In fact, the 21st Amendment, which was ratified in December of 1933, December of 33, the 21st Amendment says one thing: this amendment repeals the 18th Amendment. That's all it does. Repealed the 18th Amendment. But the damage was done. The damage was done. I find it fascinating, and probably a little known fact, we don't think about it much anymore, but women's suffrage. When we voted for Prohibition in the 18th Amendment, how many women voted for that? None. They didn't have the right to vote. Women in this country did not have the right to vote until the 19th Amendment, which was ratified in 1920. Now, the first thing women did was, when they had the right to vote, in the 20th Amendment, they changed the term limits for the President and Senate. And the 21st Amendment, they gave us alcohol back. So when women couldn't vote, we got rid of alcohol. As soon as we got women voting, they decided, you know what, that no alcohol thing's a bad idea. So thank you to the ladies in the room. So kudzu, anyone from the southeast of the United States? What's kudzu? That's right. Right. So kudzu was brought to this country in the late 19th century. In the late 19th century, it was brought here as an ornamental cover plant. It was brought here to be an ornamental cover plant. It's a great ground cover plant. It grows, it'll grow on this carpet probably if you put enough water on it, right? It grows anywhere, it spreads rapidly, and you can't kill it. And what's the problem with kudzu? It grows anywhere, it spreads rapidly, and you can't kill it. It's everywhere. Kudzu, if you go down to Atlanta, Georgia, or anywhere in the southeast, it's in the trees, the power lines, it's everywhere. So it was brought here for a desirous reason, but the unintended consequence was quite negative. So there's two very, I think, good examples of bad outcomes. Let's look at some good outcomes or unintended consequences. Aspirin. So aspirin's been around for about 2,400 years. We've known about aspirin. And aspirin was really, originally, we took the bark of the willow tree and you grind it up and you extract the acetylsalicylic acid out of the bark of a willow tree and you have aspirin. That's what aspirin is. There's a scientist, and there's only so many willow trees and you can't be debarking them all. So there's a scientist and he worked for Bayer, and he synthesized acetylsalicylic acid. That was the advent of commercial aspirin, which again is everywhere today, right? So when the patent ran off, Bayer had the patent on aspirin. Yeah, that's a Freudian slip. So when the patent ran out, of course, now everybody makes aspirin, right? So it was a pain reliever, and that's what it was used for. But the ancillary benefit, the unintended consequence of consumption of that is it thins your blood. thins your blood. It's a great blood thinner, anticoagulant. So now there's been new research. There's always research. There's been new research to suggest that maybe you shouldn't take a baby aspirin every day. I do. Cardiologists would, in this country, recommend that any male over the age of 40, if you don't have any other underlying issues, you take one baby aspirin a day. It thins your blood sufficiently so you are less prone to stroke or deep vein thrombosis, blood clotting. Makes sense. So I personally take one every day. I took one this morning, and if I'm going to travel, when I get on an airplane for any distance beyond the continental United States, I take two, the day before, the day of, the day after. That's what's recommended. Now there's some evidence that says maybe the chance of internal bleeding may usurp that benefit. But nevertheless, there is an unintended consequence of aspirin as a pain reliever, and that's a blood thinner. Horsehair. That's a strange one. In this country in 1861, we had a civil war, 1861 to 1865. And during that period, you know, the North, the Union, was fighting the South, the Confederacy. And the Union had a very strong naval blockade on the South, very strong. And we, the Union, the North, was able to inhibit the Confederacy from getting a lot of necessary goods, one of which was silk thread. And what do we use silk thread for? Suture material. Suture material. There was probably no more abundant need for suture material than between 1861 and 1865 in this country. Right? We were killing people right and left. So the surgeons in the South, they didn't have access to silk suture material. So they had to use something. You know, when you amputate someone's leg, you've got to suture it up when they've got these horrific injuries. They had to suture them. So what did they use? Well, in the South at the time, they had lots of cotton. So they took cotton thread and they sutured them with cotton thread, and that was wonderful. But the problem with cotton thread is it rots before the wound heals, and now you've got this horrible mess. So, again, necessity is the mother of invention, just like the gentleman yesterday was talking about the spanner wrench and how the mechanics would just find one, you know, they'd make their own. And, well, these surgeons that had no way to suture up these soldiers, what did they do? One bright gentleman said, hey, go to that mule or horse, cut off its mane and cut off its tail hair, and bring it to me. We're going to sew people up with that stuff. And if you've been around, you know, manes and tails, it would make a great suture material. But it does have one fatal flaw. It's not pliable. If you go to a horse mane or a horse tail, mule, same thing, in essence, the hair's not pliable. So how can you make hair pliable? Boil it. So the surgeons were having their assistants, the medics, boil the horsehair so that they could suture the soldiers. They weren't boiling it for cleanliness because they didn't know about cleanliness during the Civil War. They were boiling it only to make it pliable. But what was the unintended consequence of boiling it? Of course, cleaned it. Cleaned it. It sterilized it. So think about, before that, where did a surgeon carry his silk thread before he did suturing? In his pocket. He'd pull it out, suture somebody up, stick it right back in his pocket, go over to the next person, suture him up, put it back. I mean, the sanitation was nil. There were two gentlemen, so again, at the same time in the 1860s, there were two gentlemen. You've probably not heard of them, but you certainly heard of the name. Two gentlemen, one was Joseph Lestour, who was a French chemist, and, Joseph Lestour was the British surgeon. Louis Pasteur was the French chemist. You've heard of pasteurization, of course, and you've heard of Listerine, I suppose, the mouthwash. Right? So Louis Pasteur he was studying germs. And we have pasteurization now, right? We pasteurize a lot of things. And by the way, he wasn't looking to pasteurize milk. He was looking to pasteurize wine. He was French. They don't drink so much milk, lots of wine. I kid, but not so much. And then, of course, the surgeon, he was studying germs because he was trying to understand how come people would get infections. So he was actually using carbonic acid to sterilize his instruments. Carbonic acid. So there's unintended consequences in many things in life. We're here about aviation. We're here to speak about safety in aviation, so let's talk about some aviation examples. Certainly in my life, I started flying helicopters in '82, so turbine engines were still prominent. They were prominent in the '80s. I still flew a lot of piston helicopters, Hughes 300s, Instroms, Bell 47s, but a lot of Jet Rangers, 500s, Long Rangers, those aircraft as well. But none of them back in 1982 had a GPS in them, right? None of them. Hell, none of them had LORAN. In fact, like many people in this room, I will say my first 3,000 hours in a helicopter, I'm just guessing, I flew with not any navigation radio. Nothing. Helicopters didn't have nav radios in them when I started flying them. Let me back up. I started flying, I started crop dusting. I was a crop duster. I sprayed. I didn't have a nav radio. You know, what good was that going to do me? Right? In fact, I had one ship that didn't even have a comm. It was just 10 pounds of weight I didn't need. So today, though, we have what I characterize as near perfect navigation. I don't know how it's going to get much better than it already is. It's reliable, it's accurate, right? A regular GPS, just a run-of-the-mill, you know, buy it at a flea market. You got 50 meters of accuracy, 50 feet. WAS down to 10 feet. That's horizontal and vertical, yes, right? Inexpensive. You're not going to buy a Garmin 750 for 15 grand, but you can buy a lot of GPSs and put them in aircraft for 15 grand. A lot. They're intuitive. Who here has flown with a Garmin GPS? Okay. Keep your hand up if you've read the manual, cover to cover. Right. Okay. Raise your hand if you've barely read the manual at all. Why? Don't need to. Why do they dominate the GPS market? Who had the first helicopter GPSs? If you're flying IFR in the late 80s in a helicopter, early 90s, IFR, I promise you, you're flying a King, KLN 90 or 89B GPS. Right? The most archaic, unuser-friendly, unintuitive GPS you could have. Does King even make GPSs anymore? I don't know. I've never seen one. I doubt that they do. So today they're intuitive. You don't have to read a manual to do 80% of what you need to do, you can do just intuitively. If you want to know some of the fine details, fine, pull out the manual. But just to use it on a daily basis, a manual's a little superfluous. The displays, of course, we've got multiple layers, topography, airspace, TIS, traffic information services, traffic avoidance services, CAS, right, collision avoidance. We've got all this stuff in those GPSs. We bury all this information in there. That's super. But there are consequences to that. How about who now is worried about getting lost when you fly? Honestly. Getting lost. I'm not saying you don't have to think, well, I'm at DFW and I want to go to Love Field. Do I go east or west? Well, you look on a chart and you're going to go east. But being lost. Does anyone really worry about being lost? Really? Wow. I don't worry about it. I may not be where I want to be, but I don't know how I can get lost. So in the aircraft today, and I'm a little spoiled, I realize, but I've not flown a ship probably in 20 years without at least one GPS. I've not flown a ship IMC without 2 GPSs embedded in the aircraft, organic to the ship. And then to be honest with you, I've got my iPhone with ForeFlight on it and a GPS. I've got an iPad with ForeFlight and GPS. I mean, we've got all this. In fact, the problem can be sorting through it all. Where do I look? Where do I get my information? But I don't really worry about getting lost, and I think most of us really don't. We're not worried about busting airspace anymore. I'm not saying when you go to SoCal your first time, you're coming through Banning Pass, you aren't, kind of paying attention. But what I am saying is you now have the mechanism to avoid that airspace if you pay attention. If you pay attention. Back in the day, when you came through Banning Pass, you leave, Palm Springs and you're going to go down through Banning Pass. If you had a sectional chart shoved under your left thigh and no nav radio, how much distance did you give, how much berth did you give to Class, well, it was TCAs at the time, but we'll call it Class B now. Did you run right up on the edge of Class B as you went in through there? or did you keep a mile or a mile and a half clearance if you could? Sure, you kept a lot of clearance. Because you weren't positive where you were. You thought you knew where you were, but you weren't positive. Today, you're positive. If you look at radar images or talk to a TRACON guy today, they will tell you people are going around the Class B airspace virtually by feet. They just range in, right? And you just drive right around the edge of the Class B. But you wouldn't do that if you didn't have near perfect navigation. Scud running. None of us believes it's the right thing to do, but all of us have done it at one time in our careers. I believe that. We need to do less of that, and that's part of this presentation, but not really. But I think that these navigation systems encourage it to some degree. They encourage it to some degree. If I were going to go fly, so if the weather's bad, and I'm going to go through the regulations here real quick. Under 91, right, it used to be clear clouds. You could fly a helicopter VFR to remain clear clouds, yes? But about 5 years ago, I need to really look at the exact date. 5 years ago, we changed the regs to say a half a mile during the day and a mile at night. You had to be clear clouds on a half and a mile, okay? So let's imagine I'm clear clouds, I'm 200 feet AGL, and I've got half mile visibility. Why don't I go fly a helicopter somewhere? People do today. To fly in 300, well, I'm sorry, I've gotten ahead of myself, but under Part 135, it's 300.5 during the day and 301 at night. In this country right now, I can get op specs to fly in this country, Part 135 charter, and I can fly with a 300-foot ceiling and a half a mile of viz, and I can do the same at night with 1 mile of viz. Now that's insanity, and I hope that no one in this room would do it. But what allows us to do it? Near perfect navigation. Why didn't we do this 30 years ago flying helicopters? We'd get lost. I really do think there are people today flying in worse weather than we did 30 years ago, and it's not because we're better pilots back then or they're worse pilots today or however you want to slice the pie. It's because they now have a tool which allows them to not get lost. The displays today. You know, when you look at the displays in these helicopters today, most ships that we're delivering, that I think the industry is consuming, the buying, whether they're VIPs or utility operators or, you know, offshore, helicopter air ambulance, the displays are very compelling. And still, most of the ships are VFR. But the displays draw your attention inside. That can be very dangerous. And it's interesting, I don't have empirical data, but just from an observation, when the visibility is worse, people seem to look inside more. Because what is inside never changes. It always looks good. So if you look outside and it's a little skosh, I got my synthetic vision inside and I'm okay. Yeah, not really. That's why we call it VFR, visual flight rules, see and avoid. And even if you're IFR, right, even if you're on an IFR flight plan, if you're in VMC conditions, you still must see and avoid. You must see and avoid. That's why the panels, the windscreens are transparent. And I think it happens more in a degraded visual environment. So iPads, another great tool, or I should say tablets, but I fly with iPads, so everyone at Airbus has an iPad. We all fly with iPads. Every one of us. We have for probably now, since there have been iPads, I don't know, we've probably been doing it for 8 years or so. The iPhones came out 11 years ago, so the iPad's probably a couple years after that. And they're fantastic devices. They make it very easy because you have all the sectionals, all the WAC charts, all the low-end route charts, all the approach plates. Everything is always in there and it's always updated. Very convenient. And it has a tremendous amount of information. Well, what's one of the consequences of that? Well, if you have a lot of information, it takes time to source it and it takes time to glean what you want from it. You know, back in the day, if you're flying along, you want to know what the weather was in Butte, Montana, and if you're high enough or in a terminal environment, you call Flight Watch on 22.0 and say, hey, this is copter 1234, en route Butte, what's current weather in Butte, what's the forecast? And I could still be flying, but what do we do today? We all look down, we start screwing with our iPads, and we start sourcing that information. And while we're down there, we look, oh, let's see what the fuel price is at Butte. and which FBO has the best price? I'm not sure we all have any of us, I shouldn't say all of us, any of us have the residual mental capacity to fly a helicopter, especially when the weather may be bad, and do those extra things. Even once you have the information, you have to think to process it. So I'll give you a good example. I'm going to fly to Oklahoma City today. So Oklahoma City is basically due north of DFW. I'm going to go to Oak City. Call it an hour and 20-minute flight. The wind's at 6,000, 3, 6, and 9. So I'm going to go 360 on my heading. Well, the winds at 3,000 feet are 180 at 5. But at 6,000 feet, they're 200 at 15. And at 9,000 feet, they're 210 at 40. What's the best altitude? Can anyone tell me positively right now? No, you got to think about it, don't you? Unless you got an FMS, it's going to calculate it for you. My point is, even when you get the information, you have to think. The iPad doesn't say, oh, your best altitude is 6,000. Please go to 6,000. No, you have to think. Yeah, I think oftentimes they give us a false sense of security. We think because we have all this information, we're indemnified against a bad result. Again, that's not always the case. And no matter how many of them you're carrying. An attractive nuisance. I've flown with many people who get bored in the aircraft. You're on a long cross country, and the next thing you know, they're playing with the iPad. Now, they may be doing something aviation related, or they may not be. But it's just another thing in the cockpit to be diddling with that probably you shouldn't be. Maybe you shouldn't be. And then a physical impediment to the flight controls. So I don't know about you all, but when I fly, I've got a backup battery. Most aircraft today, though, we're putting USB ports in them. A lot of them, not most of them, a lot of them because people demand them because they want to be able to charge their devices. But if you don't have a USB port, then you've got a standby battery. So now you've got a battery and you've got a cable. And if you fly a helicopter and you're hand flying the helicopter, everyone in this room that hand flies a helicopter flies with their right arm resting on their right thigh. Where do you put your iPad? Well, some of them put it on your left thigh, right? Okay, well, that's fine. But now you can't put your kneeboard anywhere, so something's going to end up on the floor, and then we had an accident in Ireland where the gentleman set his iPhone on the floor of an EC-120, it vibrated forward, it fell over the lip of the floor, jammed the controls, jammed the pedals, right? Let's look at a couple of accidents that have occurred. That's just an artist's rendering, of course, but the first EC-145 that we delivered in the civil market in this country is destroyed, it crashed, no fatalities, remarkably no fatalities. And I pose the Autopilot played a role in it. Not that the Autopilot failed. In fact, the Autopilot worked perfectly. The Autopilot in these aircraft is exquisite. But much like your computers, it's going to do exactly what you tell it to do. It does not have its own mind. It does not say, oh, gee, that's really not what this person wants in this situation. If you tell it to do X, it's going to do X. So when we look at digital autopilots, the systems that we have today that you're all flying, whether it's in a Leonardo, Sikorsky, Bell, Airbus, it doesn't matter whose product. These systems today are phenomenal. Who flew autopilots back with the analog stuff? Anybody fly old analog autopilots? No? You were lucky. So Victor Airways, 4 nautical miles each side of the center line, right? You needed 4 nautical miles each side of the center line because the autopilot wandered around, just wandered around. They weren't very, the fidelity was poor, I'll just say that, compared to today. Today, when you couple up, it's locked on. It's like a laser. You can have a 40-knot crosswind shooting the ILS somewhere at 120 knots, and those needles don't waver. They're awesome and very reliable. Very reliable. When you press altitude, it couples to altitude. I don't think there are very many of us that have flown a digital autopilot that have pressed altitude and it didn't couple to altitude. Works every time. But we become complacent because of that. It's very easy. Humans, and this isn't our fault, humans are designed to find shortcuts. That's actually in a presentation later today, but we're designed to find shortcuts. And a shortcut can be, if you know doing X gives you Y result, You stop confirming the result. You press button, light turns on. How many of us, when you turn a light switch on in your house, look at the switch to make sure it's actually on? You don't, not unless the lights don't go on, right? And imagine if it wasn't a light illuminating the room, would you notice? Probably not. We don't confirm something we know is going to work every time. So in these autopilots, when you depress something, it's going to work. We stop confirming its function. So the accident happened in 2009, and what had happened was the pilot was flying along, and I can't tell you the exact altitudes, but about 4,000 feet, and the pilot decided to descend down to 2,000 feet. So altitude acquire was selected and entered, and the ship started the descent. Okay? Now, one of two things either happen now, because once altitude acquire in our aircraft, probably anyone's aircraft, whatever we call it, is really not a mode, it is a desire. The mode is vertical speed. Vertical speed is the mode. So once I tell the helicopter to descend from 4 to 2, altitude acquire is up, but what is driving me is vertical speed. Makes sense? And in our products and many other people's products, if I do nothing, the ship's going to auto-level. And so in our product, at 60 feet in this particular helicopter, at 60 feet, it's going to level off no matter what altitude you put in there, if you're coupled to a pitch mode. And in this case, altitude is a pitch mode. Altitude, vertical speed is a pitch mode. So as I'm coming down, it's going to level off. But what if I engaged altitude acquire? That engaged it. If I press it again, what do you think that does to it? Disengages it. Now I don't have a pitch mode engaged. So now where will it level off at? The dirt. It will not level off because you've decoupled from the pitch mode. Does that make sense? And there's another way it can happen. Let's imagine that altitude acquire was properly selected and it was trying to level off, but the collective had insufficient power was allowed. It's only a 3-axis ship. This is only a 3-axis autopilot in an EC-145. So the helicopter can't move the collective. So if you're doing a descent from 4 to 2 and you have the collective down, what will happen is when you get to 2,000 feet, the ship will level off. And then if it has insufficient power to go, let's say 120 knots at 2,000 feet, it'll start slowing down and slowing down. And when it gets to 60 knots, it says, I'm not going slower than 60 knots. That's as slow as I'm going. And then it starts to descend. One of those two things happened. And the autopilot was absolutely sending the signals in the cockpit saying, I'm descending, right? We have attraction frames. There's a lot of indicators. But if every time you ever depress the button, it does the right thing, and people say, well, why would the person double press it? I don't think that was intentional. That's what I do think happened. If you press the button and you're in a little bit of turbulence and you press it again real quick, you better confirm you didn't double press it, because if you have, you've just decoupled. It's easy to do. It's also easy to capture and understand. It's easy to resolve. Not if you're not paying attention. Modern turbine engines, another element in our industry that is fantastic, but there are some consequences that maybe aren't so fantastic. The first one, I think, is the biggest one that I personally have had to contend with, and I think the industry has struggled with a bit, and that is these aircraft have so much power now that people have become airborne on one engine with a twin-engine helicopter. So, think about, now we have single crystal blades where the alloy has very little interstitial space. So these are very dense materials. We can put lots of heat in it. Heat's power. I think an Ariel engine, we get about 26% more power out of an Ariel engine today than we did 30 years ago. And, it's through FADEC and through these new alloys, these new construction techniques. So we had, as an industry, and Airbus as well, events where people were taking off in a twin-engine helicopter with one engine at idle and one engine at fly. It happened fairly frequently. And so you have to go back and you have to imagine, well, why are pilots today doing that? I have never become airborne. When I was flying 222s or BO-105s or Twin Stars, the old Twin Stars, I never took off on one engine. It must be because I'm just a superior pilot, right? No. And by the way, I'm going to preface this by saying I have no recollection of ever trying to take off on one engine. But I may have, I don't know. Why didn't it ever happen to me when I was flying those old aircraft? They wouldn't go. Yeah, load up a Deuce to near gross and try to go fly on one engine. Allison C-30P, it just goes, ugh. Right? They won't go. Neither will an old BO-105, an old Twin Star. They didn't have the horsepower to do it, but now they do. So some of the errors that pilots made in the past couldn't go to fruition because the aircraft didn't have the power to go to fruition. Now we do. Now we do. Now I'm not saying you're not pulling it into the 30-second limit taking off on one engine, because you are. But I'm saying it'll go. It will absolutely go. I think sometimes we fly faster than is safe and we fly lower than is safe because we've come to the conclusion, an erroneous conclusion, that engines don't fail. Now, I will grant you it is rare. But if you're flying around, so when we talk about flying around scud running, or maybe you're doing it legally, your op specs say you can fly in 301 at night, and you're out there flying in 301. Okay? You shouldn't be doing that, but let's say you are. You might not want to fly at 150 knots. You may not hit an object, but if your engine quits at 300 feet, AGL, in a mile viz at night doing 150 knots, I pose you probably have a problem. So this accident happened here in Dallas. It was in Augusta. It was a power. There were two of them. The first one happened in 2002. It happened in Fort Worth. It happened on the top of Harris Methodist Hospital in Fort Worth. In my last class, there was a gentleman who's actually been to that pad. Has anyone here been to those pads? So there are two pads at Harris Methodist. They're oriented north-south, and they are huge. I'm sure they're more than 20 meters in diameter, and they're two abeam each other. They abut each other on a north-south axis. I'm just going to guess and say there's 200 feet of surface up there. I mean, you could land a stall aircraft up there. So what had happened was the organization here in town had just got them their EMS configured, now, helicopter air ambulance. And they had just dropped a patient off somewhere else. I don't know where else was, but they dropped a patient. And they were going to do maintenance on the aircraft. So the ship was going to Grand Prairie, and actually the operator is co-located with us in Grand Prairie. So they stopped at the hospital to pick up their tow bar so that when they landed at Grand Prairie, they could tow it in to do maintenance. It's a brand new ship. They didn't have tow bars, so no problem. So the helicopter landed while one crew member, so the pilot lands the ship, he takes both engines to idle because of noise abatement and stinky turbine fuel odor, right, all that stuff that hospitals don't like, and I understand that. He takes both engines to idle. One crew member gets out, goes into the elevator shaft thing where they keep their stuff, and he or she gets the tow bar and is, bringing it back to put it in the helicopter. While that's happening, the pilot in the helicopter is explaining to the other crew member how you do running takeoffs. The crew member asks, well, what's a running takeoff? Why don't we take off like an airplane? And why would you do that? Why would you not do that? So they were chatting about doing running takeoffs. That's innocent enough. So when the crew member got back in after stowing the tow bar in the baggage compartment, they got in, buckled in, said, I'm ready to go. And the pilot says, I'll just show you a running takeoff. It's a great opportunity. We got lots of room. I'll show you one. So unlocked the wheel locks, the brakes, the parking brake, pulled some pitch, started rolling. Okay, here's 21 feet off the edge to the parking deck. It won't fly with both engines at idle. That's what they did. 2 engines, ground idle. It's not hard to be distracted and make an error. That's why we have checklists, right? But it's easy to be distracted. I'll give us some other examples here in a moment. So that was a horrible accident, but kudos to Augusta and their product. That ship, no one was killed. I don't think it had life-threatening injuries. I think somebody had bilateral femur fractures, which is bad. You don't want that, but it's not like a unilateral spine fracture. So the aircraft was very, it protected the occupants. Then about a year later, it happened again in a similar way, but different, of course. It's always slightly different, In this case, the pilot took off with one engine at fly and one at idle. One at fly and one at idle. And, we take off into the wind, right? So the pilot takes off into the wind, recognizes after departure, oh my gosh, I got one engine at idle. Now, and again, I'm not really criticizing the pilot, I'm not. It's because we don't know how we will always behave until we're in that situation. But what this pilot did was he did a 270-degree turn back and landed on the rooftop downwind on one engine. Well, that didn't go well. No one in that case was even very seriously injured, but the ship was seriously damaged. Of course, all the pilot had to do was just take that engine to fly. I mean, it's a flip of a switch. It's literally the flip of a switch. If you want to go start up, and I won't speak about everybody else's products, but if you want to go start up an Airbus helicopter right now, go in, turn the battery on, and then there's two switches, and they're called engine 1 and engine 2 mode selectors, and take it to fly. It's running. It's running. So if I take off with one at idle and one at fly, all I really have to do to get the other one at fly is go, done. But you have to be aware enough to do that. So I don't want to go into the specifics of what caused that, but the fact is he took off with one engine at idle and one at fly. It can happen, and it happens in a very insidious way sometimes. So let's take EMS as a good example of how this can happen. And this wasn't the case for this event, but you can foresee that this could happen, where you're flying a helicopter air ambulance ship, and they tell you to go to Hospital A, so you're going to go to Hospital A. And you've got both engines on idle, you've just taken one to fly, and when you take one to fly, dispatch calls and says, hey, we've got to change, you're going to a scene, a motor vehicle accident, and stand by ready to copy coordinates. I'm like, okay. So you start copying the coordinates down, you're putting them in the GPS or the FMS, and then they're like, and you're talking, and the crew's trying to get a report. You can easily see how a pilot could say, okay, you ready to go? Ready and back? Yep, okay, let's go. Or picking up an IFR clearance. So it's my practice. I'm not saying it's everyone's practice, but I'll start one engine, then I get my clearance on request. And then when I get my clearance, I start my second engine. Because at least operating out of here at DFW, if you're not pretty sure you're going to get going, you can be out there for 20 minutes sitting on the pad waiting to go. I don't got that much extra fuel. And you say, well, you're at ground idle. Come on. We're mostly carrying 2.5 hours of gas, right? So fuel is a concern. So imagine you're out there and you've got one engine at fly, right? Let's say both are at idle. And they say, hey, you ready to go? Yep, ready to go. And you bring number one to fly, and they say, oh, we've got an amendment to your clearance. Ready to copy? Sure. By the way, that's a whole nother presentation, but sure, I'm ready to copy. We say that even when we're not ready to copy, right? If someone says, are you ready to copy? How many of us say, stand by 5? Because you're flying single pilot IFR in a helicopter. Sometimes you need a few minutes to get your stuff together. But we don't. We say, yep, ready to copy. So you copy down the clearance, and they say, hey, we got a 747 inbound to DFW. You need to expedite. Okay. Too bad. One was at fly, one was at idle. It happens. There's an unfortunate accident. It was a Sikorsky. It was being operated by a fine operator. I mean, honestly, in my opinion, one of the best that there is. It was a very unfortunate accident. It happened in 9 as well. It was flying offshore. I think it had left Fushan. I may be mistaken about its departure point. I should look that up. But anyway, it was in the Gulf. It was going offshore. 2 crew members. And what had happened was they hit a hawk doing 135 knots. And this was a very difficult one to sort through because the bird did not penetrate the airframe. But it was the cause of the accident. So you can imagine there's 2 pilots in a helicopter. We're level doing 135 knots. So any one of us, myself and another person in this room, we're flying a helicopter. We're coupled up to the autopilot. We're going offshore IFR at 135 knots in cruise flight. The autopilot's flying the helicopter. I'm not flying it. And by the way, to some degree, it's a misuse of the crew to be flying a helicopter. You don't spend $10, $20 million for an aircraft to hand fly it. You spend $10 to $20 million to manage the aircraft. You let it fly so you can do the other things, right? So unfortunately, what happened was this hawk struck the windscreens right between the pilot and co-pilot, at the center post. It didn't penetrate the aircraft, but the percussion from the impact took both fuel flow control levers on the 76 and put them back to idle. They didn't shut them off, just brought them to idle, instantly to idle. And that's virtually unrecoverable for any helicopter. For any helicopter. Because think about, I know some of you fly twins, maybe all of you fly twins, but when you look at a twin-engine helicopter, we have two speeds. One's all-engine operating VNE, all engines AEO VNE, but then we also have OEI VNE, one engine inoperative VNE. Then the difference is blade drag in est. In other words, if I'm flying along on two engines, remember we only have to show a single failure. If I lose an engine, then I fall back to let's say 110 knots, just to use a number for an aircraft. Why? Because if the subsequent engine fails, I'm in a good position to do an auto rotation. But if I remain at 135, 140, 150 knots, the blade drag's so great, I won't have 1 second to respond to the failure. I will stall the rotor before that. So that's why we ask you, we tell you in the flight manual, one of the limitations is, if you're on one engine's inoperative, to slow down. But these gentlemen unfortunately didn't have that opportunity. Both engines went to idle instantly with the autopilot flying. And I know there was a lot of testing done with the NTSB, and I don't know that anyone ever safely landed the helicopter, even when they knew it was going to happen. And it wasn't the helicopter's fault at all, nor was it really the pilot's fault. And it's probably unfair to say lack of regulation, quite honestly. It's probably a little harsh on my part. But what I want to get to is, on the 76, and this operator is a fantastic operator, but when they buy the aircraft, and they do it from all manufacturers, when they buy an aircraft, they configure them themselves. So they take them down, they paint them, they take stuff off, they put stuff on. I mean, they're a fantastic operator. Well, it's my understanding on this particular aircraft, the windscreens were originally glass, but when it had a problem with one of the glass windscreens, so they put cast acrylic on. So cast acrylic's cheaper, lighter, right? You don't need glass windscreens. You're flying offshore in the Gulf of Mexico. And what are the odds of a bird striking? If that bird had struck a foot to the left or a foot to the right, maybe it brings one engine to idle. That's just a messy bird strike. It happened to hit at the most inopportune place at the most inopportune time and cause the accident. The unintended consequence of the action to save weight, to make more profit, right? And possibly even from a, get time out of service, I don't know. So the decision wasn't a bad one. It just had a consequence no one could foresee. And unfortunately, it cost some people their lives. That's why we call them accidents, by the way, right? If we didn't call them accidents, we'd have to call them purposes. We don't do that on purpose. No one got up or no one designed or no one thought that this could happen. It was not foreseeable, not reasonably foreseeable at the time. So all of this really, to come to my last few slides, and that is, I think everything I've spoken about thus far makes perfect sense, and I think we all spend a good amount of time thinking about these things. I believe that as an industry, we try to look for the reasonable consequences of an action, of a change. I think we do. What I think we do poorly is I think we still foster and promote unsafe acts, and we ignore good acts, the proper job, the proper decision. I've got a very good example, but before I go there, oftentimes people tell me, they'll say, yeah, Bruce, but I just get so much pressure from the operator to go. There's just so much pressure to go. And I understand that. I know what they're talking about, right? When you go to an accident investigation, that's one of the first questions they ask. Are you being pressured to fly? Or do you feel that pressure here as an organizational problem or an organizational issue to force you to fly? And I'm not saying those places don't exist. I'm not. But I pose this. Be a little introspective and really ask yourself, when you have flown when you shouldn't have, or maybe in hindsight you shouldn't have, where'd the pressure come from to go? Because I believe it came from within. It came from you. So I'm not proud of this, nor am I ashamed of this. This is just a fact. If I, in this hand, could weigh the number of times I took off, or I took a flight, or I did a mission, or I performed some act in an aircraft, whether it be a maintenance action or as a pilot, when I shouldn't have. When anyone in this room would stand back omnisciently and say, Bruce, that's stupid. Don't do that. That's one weight, that's one measure. And over here, the number of times I made a decision not to do something, not to take a flight, not to perform an action, not to do some maintenance thing at that time, right? I'll explain more later. Which way do you think that scale falls? Do you think I've taken off and been airborne more often and said to myself, that was dumb, I shouldn't be here? Or do you think I've not gone and said, well, you know what, gee, Bruce, I could have probably done that flight fine. Be honest. I know which way it falls for me, and it doesn't do this with me. It goes thunk. Across my 36 years, it goes thunk. Now, if you'd ask over the past 15 years, is it balanced? I'll say it's balanced. I still make error. But there's other times I just say, you know what? No, the opportunity for it to go bad is too great. I'm not going to do it. Now, if it turns out fine that I could have gone, so be it. But look within yourself and ask yourself how many times you've done that. Because we've all done it. We've got to start being more conservative in our behavior. And until you can honestly say that's balanced, or maybe, quite honestly, if we want to err on the side of safety, that's one of those platitudes, right? Err on the side of safety. Then really, the number of times you've done something that maybe you could have flown, you should drop this way. It certainly has to be balanced, and it probably really should be this way. But I pose in our industry it's not. And I think if we all look within ourselves in our lives, I'm not saying in the recent history, most of us here have been around a while, right? I don't see very many 20-year-old people in the room. So, but we have to recognize that the pressure to go is often from within. It's not management. It's me. I want to go. I want to do the job. Who recognizes that image? A couple people, 4 or 5. That's a Bell Long Ranger owned by the U.S. Park Police. That's sitting on the bank of the 14th Street Bridge on the Potomac River. It's January 13th, 1982. And there are 88 dead people there. 88. I should have said 78. There were 79 people aboard the aircraft that crashed into the bridge. 5 of them survived, and there were 4 people who were killed on the bridge. The conditions at that moment, 200-foot ceiling, 0 visibility, 24 degrees Fahrenheit, moderate snow. How many people would like to say you would fly that helicopter in that condition? How many of your operators, the people that you work for or yourselves, would say, well, that's a good decision. I'm going to fly because I'm going to save somebody. Right? I've had people tell me, oh, but they were saving lives. They had to go. I'll come back to that. So on this day, there's an Air Florida ship. By the way, the captain on that ship had busted his check ride 3 times, twice in the previous year. They were not well trained or well versed in cold weather ops. They loaded the ship up at Reagan National, DCA. At the time it was Washington National, but Reagan National now. They loaded the ship up. It was snowing heavily. And when they went to be pushed back off the gate, the tug couldn't move them off the gate. It was too slippery. The tug just spun. So the captain, because he's trying to do the right thing, he wants to go fly, right? He's got a boatload of people. He's got 74 passengers, himself, and 4 other crew members on board. So he does something that doesn't sound so ridiculous, but it is strictly prohibited by the flight manual. he deploys the buckets and adds power to push himself off the gate. So he puts the thrust reversers out, adds power to the engines to help the tug push him off. Even that won't push him off. So they abandoned that illegal act, prohibited act, I shouldn't say illegal, prohibited act. And they go get a tug with chains, and they hook that tug to the 7.3, and they push it off. Now, while he was backing off or trying to back off the gate, he didn't turn on his EPR heaters. Now, I don't fly airplanes, some of you do, but EPR is engine pressure ratio. And from what I'm told, I'm just a helicopter pilot, it's kind of like torque. Just think about it like torque. It's a measure of power. It's a measure of power. So when you're flying a plane like this, you know, you've got all your ref speeds and you've got all your power settings, and you know when you go to take off, you're going to set your power to 85% torque. It's really not torque, it's an EPR setting, but for our purposes, it's torque. But they don't turn on the EPR heaters, and EPR really is just bleed air out of a portion of that engine. But with no EPR heater, you don't bleed air, and if you don't bleed air, you don't get a good EPR value. So they push off, and they go to the de-ice pad. So they go to the de-ice pad. Now again, you have to just realize how congested the airspace is this day, right? It's 200-foot ceiling, no visibility. Everyone, you know, it's an arduous, difficult process. But they get de-iced. After they're de-iced and they're waiting in line for their departure clearance, their turn in line, the captain asks the first officer, the second command, to keep her up close to the MD-80 ahead. Keep her up close to that MD-80 ahead. Why? Exhaust heat. He's like, shoot, man, I've been waiting in line. I don't want to go back to the de-ice pad. Let's keep this baby right up close to that MD-80 ahead, and his exhaust heat will keep me from icing. And again, at first light, or maybe after a few drinks, you say, well, that wasn't so dumb. Well, what's heat do to glycol? It evaporates it, right? But that didn't really matter because that isn't what killed them. They didn't fly long enough to get dead because of that. When they finally got to the end of the runway, they got their clearance. They were cleared to go. They applied the throttles. They went to whatever their EPR value, 85% torque. They went to their EPR value, and immediately they recognized they didn't have sufficient thrust to go. They're like, well, this doesn't seem right. But neither of them were well adapted to that environment. So they thought, well, this must be because it's cold and snowing. I don't know. Seriously. They didn't say that. But I mean, so they're running down the runway, and the whole time, they're like, this doesn't seem right, Joe. I don't know, Bob. I don't know. And they barely get to VR, rotation, and they rotate. And the stick shaker's going, and the plane isn't flying. They went to 352 feet AGL. That's how high that ship got. It crashed 0.75 nautical miles off the end of that runway. They did not go 1 mile and didn't get to 500 feet. They did finally realize they had a problem, and they applied full throttle, you know, right before impact. That really wasn't part of this program originally, but I thought it's so interesting. I mean, the pilot violated 2 major restrictions in the flight manual, just blatantly violated them, all right? And then quite honestly, you know, we all know when you sense something is wrong, when your gut or something is amiss, stop. Stop. Because I'm telling you, it's normally right. What I do want to talk about in more detail is park police, the Long Ranger. So again, it's 200 and 0, 24 degrees, moderate snow. An airliner's just crashed. An airliner's just crashed, by the way. What added to the problem this night, or this afternoon, evening, early evening, what added to it was the fact that the DC Metro suffered its first fatality in the Metro line, and they'd shut down the underground. The Metro was shut down. So now all the people that normally would be taking rail were now on the streets. That's why the 14th Street Bridge, which is really 4 different spans, was congested. It was horribly congested. So they get a call and they go out, and they're about 3 miles away, and they fly up there and they ostensibly save. They do drag 5 people to shore. Let me say it that way. Because people say, well, they saved them. I don't know if they did or didn't. Because I don't know what would have happened had they not drugged them to shore. By the way, that bridge, the span that was hit, was renamed for the one man who there was a hero that day, in my opinion, was the man who, I don't know well, we know his name. I don't know, of course, we can't know why he did what he did, other than he was just a gentleman. But he handed the life ring to the 5 people who survived. When the ship came over, he's like, here, Patty, take this. Nope, you're next, go. You're next, go. And when the ship came back, and he was the last guy in the water. When the ship came back, he wasn't there. That's the hero that day. But again, I'm digressing. So let's think about this. That pilot launched in that weather to go save people. Okay? There's the image. Just looking at the image, is that ship configured for rescue? No, it doesn't have a sliding door, doesn't have a hoist, doesn't have rappelling rings. What they have is a nylon rope and a life ring off a boat they're dragging across the water. And people say, well, Bruce, that's okay. They're saving people. I disagree. It's fine for the 5 that lived. I agree with that. That's great. Let's change it up. Let's make it a little more, honestly, if you did this 9 more times, I pose 8 of those, they crash. Here's why. If you're hovering around up there and you've got that 15-foot long line, how much water are you regenerating through your rotor system when you're hovering around over the Potomac? You getting water into your rotor disc and your tail rotor and everywhere? Yep. Why isn't it icing up? Why isn't he icing up? Because there's 10,000 gallons of turbine fuel in that water. But I'll bet that pilot knew that before he went. He said, in his risk assessment, he said, I'd probably ice up, but since there's 10,000 gallons of turbine fuel, I probably won't, so I'm going to take that risk. Come on. So let's make it something that would be very possible. Let's imagine as he's re-ingesting that rotor downwash through that water, he freezes his tail rotor up, or he has a mechanical failure, an issue, a flame out, whatever the issue is. Is that, I'll even go so far as to say, likely? I wouldn't want to do that. And let's imagine he had that event right there. Well, there's 2 people in the helicopter. There's another guy there, probably a couple there. So let's change this scenario just slightly. And let's say that when he was dragging the first patient or the first survivor to shore, he had a tail rotor loss of control and he spun it in and killed everybody on that shore. What would we say about that pilot? Honestly, what would we say? We'd say, idiot. That guy's so unsafe. That's what we would say. I don't believe for a second that isn't what every one of us would say. But because it turned out okay, let's give him 4 awards. HAI gave him an award. Crew of the Year. Really? I'm fascinated by that. Actually, I'm disappointed in that. Now, that was 82, but we still do it today. We still do it today. We look for somebody who's going to do something heroic with, valor. And I'm not saying that there isn't a place for that. I'm not saying that properly trained crews in proper equipment, in proper circumstances, there isn't that. I am saying, jumping in your white stallion, Lone Ranger up to save those people was not the right thing to do. It was fortunate that it turned out the way that it turned out. But I, for one, would not stand before you and say, I'm that person, I'm proud that I did that. Because I'm not that person, I wouldn't be proud that I did that. And we shouldn't reward that. I'm not saying you should castigate the guy, but I don't think you should give him awards. Because the problem with that is this. If we're going to reward that behavior, and that's what we did, we rewarded it, do you think you're ever going to stop it? Never. We're never going to stop it. We're always going to have people doing those things. We stand back in conferences like this oftentimes and say, well, we're going to be safe and we're going to do X, Y, and Z. Oh, but somebody did something incredibly stupid that turned out well, give them an award. We cannot do that. Little known fact, the Maryland State Police, if you're not from the United States, you probably don't know this, but if you are, you probably do. The Maryland State Police has a very robust helicopter operation in that part of the world, Maryland. They have jet rangers, not long rangers, jet rangers. Their crews are trained for rescue. At the time they were flying 206s with hoists, rappelling beams, billy pug nets, a rescue swimmer / paramedic, and a pilot. They trained a lot to do this very mission. This very mission. One of them was at Martin State Airport, 40 miles distant. That person couldn't get there. I mean, not the most desirous person is going to make it 40 miles in no viz. But there was a ship at Andrews, about 10 miles away, only about 6 miles further than the Park Police ship. And if you're familiar with that area, if you're up at Andrews, all you got to do is just drop off the hill down into the river basin and go north on the river. I mean, it's right there. And that pilot was there that day. The pilot at Andrews that day, his name was Jim Watson. And I worked with Jim for 20 years. Jim didn't go. How hard do you think it was for Jim not to go? They're trained to go. He's got a crew member right there ready to go. Everyone wants to go. It's 200 and 0. It's below his minimums. He can't go. And he doesn't go. He did the right thing. Does anyone here know that? I'm positive this is the first time you've heard his name. But certainly the Maryland State Police came up to him and congratulated him on his good decision, right? Of course not. The aviation commander didn't say a word to him, neither did the unit commander or the chief of the Maryland State Police. No congratulations for Jim. No thank you for doing the right thing. Do you think it still bothers him to this day? Do you think he still wonders, man, if I'd just gone, could I have? Is there someone in the water? Maybe that guy that saved everyone or helped, maybe he'd be here today. Do you think he has that? Yes. Did he do the right thing? Absolutely. And until we start, and I say we, the people in this room, until we start acknowledging good behavior and not rewarding bad behavior. I'm not saying you fire the guy that did this, but I'm saying you don't give him 4 awards. He actually retired from the Park Police and went on a speaking tour for 1 year. Went to Phil Donahue, Oprah Winfrey, all the things. And then retired. He was a hero. Sure they do. They have 412s now. And they were in danger of losing them all. The Long Rangers. Yeah, absolutely. Sure they do. The Park Police owns Washington, D.C., basically. Reagan National is on Park Police property. So, yeah, we exist in a society where we want to profess safety, and again, I'm here doing the same thing, but there's a innate human desire to say, that guy's a hero, let's make him a hero, look what he did. Let's really do look what he did, or she did. Let's examine it. And let's also look at the other people and see what they did or didn't do. And in all of our organizations, there are people today in every organization that we all work with that are making great decisions this moment. Acknowledge those great decisions. And that doesn't mean every day you got to be out there with a smiley face sticker. But what it does mean is if you do something good, if you make a decision, if you make that decision that tips the scale this way, instead of just ignoring it, go up to them and say, you know what, I know that was a difficult decision to turn down that flight, but thank you for making that decision. I appreciate that. Even if, especially if, it turns out they could have gone. Because they need that reinforcement. They need that reinforcement. They need to hear from somebody, oh man, I could have done it. They need someone to say, and it doesn't have to be management to subordinate. It can be peer-to-peer. It can be up as well. It can be somebody saying to you, hey, you know what? I know that was a tough decision. Thank you. That was great. It can be, just someone you work with. It could be the technician. It can be you to a technician. Hey, Mr. Mechanic, I appreciate the fact that you said enough. I got to have some lunch and I got to have some rest. I can't continue to do this. Thank you. Right? I appreciate that. That's all I have for this presentation. If anyone has any questions, I've got a few minutes to answer questions. And if not, because normally there are not, I do have 2 more things I want to talk about very quickly. The first, when we look at safety, so many things on helicopters are so freaking expensive. So safety has a cost. It doesn't always have to be expensive. So a couple of items. The first one is on our helmets, and actually it's on my motorcycle helmets too. This is a little, I can pass it around if someone wants. So what it is, it's a little adhesive, reflective, waterproof little tab, and it has a paper card inside it. You pull the card out and you write your name, your address, your emergency contact, your allergies, your blood type, your religious affiliation, whatever it is you'd want a first responder to know about you, you write it on that card and you stick it on your helmet or your headset. Then, God forbid something happens, when they're going to type and cross your blood, they know what blood type you are at least, right? I mean, or if you're allergic to penicillin, they know you're allergic to penicillin. Because, odds are, if you're in an accident, you may not be in the best condition to provide all that information to the first responders. So those cost $1 on Grainger. Anyway, so I think they're a great idea. This is, hopefully this, I would say inexpensive. It is, relatively speaking, in aviation. It's $50, which seems insane to me, but that's what it costs. Does anyone fly with these? I know TC does now. You do. So what is this? Yeah, pigtail, quick breakaway. So if you've flown in a helicopter, either as a passenger, a crew member, you've either seen or done it yourself, you've got out of the helicopter with a headset on and then, had your head ripped back a little bit when the headset falls off, or, right? Those things happen. And if you're wearing a headset, that's just a little embarrassing and maybe you damage a $1,000 headset, but it's not catastrophic. But what if you have an accident in a helicopter, and now you're trying to get out of the helicopter, and imagine this is not a pigtail, or this is indeed the cord to the helmet. If you're in a helicopter and it's laying over on its side, this is a 294, U294 plug, standard in all the helicopters you fly, I promise. If it's plugged in, it's either plugged in down here like this, or maybe it's plugged in here, or it's plugged in here. Okay? And when you pull them down on that axis, they come right out of the plug, yes? Try to pull it out this way. And you say, well, that'd be stupid. Why would I do that? Because the helicopter's laying on its side. And now you're trying to get out. And it's on fire. Or it's submersing in the water. And you're wearing a helmet, not a headset. So the helmet, if it's properly fitting, it is not coming off your head. If your helmet comes off your head because of this, you shouldn't have been wearing the helmet because you didn't have it properly fixed. You can't get out. You can't get out. Buy these. We gave 100 of these away a couple weeks ago at one of our customer symposiums. I think it's headset.com. You can have your own avionics people make them. It's just a male and a female 294 plug. Put a small cord in it, but it's not an extension. It's a quick disconnect so you can get out of the aircraft. So safety doesn't have to be expensive. Safety can be something as simple as that. And I do believe this. So this is one of my, I'm harping on this, and I got these made, and when I got a $5,000 bill for those things, I about died. But anyway, that's aviation, right? I can't complain about cost because I know things are expensive. But anyway, I do believe this is going to save somebody. It's going to save somebody. And it might be you or one of your crew members. So again, that's all I have. I do appreciate your attention, and I wish you well in the rest of the conference. So thank you all. Yes, TC?
Let's talk about the ambulance for a second.
Uh-huh.
Understanding, flying with an autopilot and all that. It's so common that they have a perfect good aircraft, and they barely turn on that autopilot when they're, going from point A to point B.
Right.
Have Airbus changed the way they're training? Because I remember going through the DC-135 school way back. Have they changed that? The emphasis that then the way they work? Honestly, I think it was weak, and people don't get it.
Right. So good question if you didn't hear. So the question is really, is at Airbus, are we doing something where we're encouraging more use of the autopilot, not less? And the answer is yes. What we have to overcome is, TC, though, there are many people in this room, probably the fact that you're here makes you the exception. I don't mean that flippantly, I mean that truthfully. Most people that are here want to know the entirety of the systems. We have customers that have come through training that don't even want to know how to use the autopilot on a 145. I'm like, the only reason you should really buy it is because it has got 2 inches of IFR and has an autopilot. Use the autopilot. And to TC's point, I know People say, how many hours do you have in this helicopter or that helicopter? And I hate that question for a lot of reasons, but the fact is I have very little time hand flying, so he flies EC-135, 145s. How much hand flying time do you have, TC, in a normal just takeoff and landing? If you're just going on a ferry flight, 2 minutes? Minute on the departure? Minute on the arrival? You don't buy a $10 million helicopter to hand fly. You buy these systems to use the autopilot. So TC is, he's not my straight man, but he could be. We have all got to start using the systems, and you have to use them every day, all day, when you don't need to use them. If you're going to wait to use an autopilot on a VFR helicopter that has an autopilot, when you get in the clouds, you will fail. You must use that autopilot all the time. And so we do, TC. We try desperately to get people to use the systems as they're installed and in the way they're designed to be used. Unfortunately, not unfortunately, that's not fair. Some people are willing and able to do that, and some people are a little resistant to that. It's disappointing, quite honestly. But, we had I won't even say the make and model because that would give it away, but we had a 4-axis autopilot helicopter have a hydraulic malfunction, and the crew decoupled the autopilot and flew it home. Why? The autopilot doesn't give squat if it has that hydraulic system. It will fly fine on one hydraulic system. It's right. Right. I know. I think it is what people have grown up doing. I think it'll get better as our industry as we have pilots that grow up with these systems. It's interesting when you go fly in a simulator. So we have simulators, of course. And you don't have to do it in a simulator. Don't do it in real life because it's too dangerous. But in a simulator, it's fascinating. You'll have a guy on an autopilot in a 135, 145, and they're flying on the autopilot. And you'll put them in a degraded visual environment. So you'll bring them down from 1,000 to 900, 800. You'll finally get them. And when you get them in such bad weather that they're still choosing not to go IFR, they're choosing not to climb on the autopilot. They're choosing not to do that. What do you think many of them do when they're in 300.5? They decouple. And here's why I think that they do it. They do it because the autopilot won't maneuver sufficiently aggressively that they are capable of maneuvering in that environment. That autopilot's not going to roll into a 45-degree bank turn, but they will. The very thing that's saving their lives, they decouple from. It's unbelievable, but it happens. It happens. So and honestly, I think if there's someone in this room that if you really, really, really think, have you ever done that? I would say you'd have to say, yeah, I've probably done something similar to that. You're like, oh, I'm going back to what I know. What I know is hand flying. I'm going to do that. No. We have to start looking at, and again, it's my next presentation talks about this, but we have to get away from the old habits, the old way, and, oh, well, that's what we always did, and, no. These systems are so capable today. So capable. Double click the top coolie hat and sit back and smoke and joke and read the paper. You're not going to hit anything. You're going to climb. You're going to hold your head. All manufactured ships are robust. They're capable. Again, we know from an accident statistic that the pilot, the human element, is 400% more likely to be the cause of the accident than the airframe. But we spend, in my mind, we don't spend enough time looking at the human element. When we go to an accident, and I'm sure there are people in this room that have been more than I have, I've probably only participated in maybe a dozen helicopter accidents. Fortunately, or unfortunately, only a dozen. The first thing everyone does is, we all go out to the aircraft and start taking pictures of the helicopter. Well, you know what? There may be some evidence that's going to waft away in the snow or the rain but the most critical evidence isn't there. And if the crew members are all deceased, still there's more information from people out there. It's fascinating to me, we're required to get a 72-hour pilot history on a pilot, right? So if I'm killed in a helicopter accident, somebody should be knocking on my wife's door saying, hey, I need to talk to you about Bruce. I need to talk to you about his last 3 days of life. I've never seen one. I hear this a lot. The widow's very distraught. There's really, we've got enough background to know, no, we don't have enough background to know. Was the person having financial problems? You know, was the, and this is one that's true, I won't go any further than just to say this, was the man's girlfriend getting ready to tell the wife that they were having an affair? Do you think that affected the person's mindset that was flying the ship? And there's a lot of that. We have to understand that, but we don't want to. That's dirty and it's difficult. You know, helicopter components and parts, they have no feelings. They have no. So we pick it up and say, oh my gosh, I think that's out of conformity. That's supposed to be 12 inches long and it's 11.99999 inches long. Now it's the static wick on the tail, and what happened was, the ship caught on fire. So we've got to look at the human element. We've got to look at the human element. And we have to be men and women enough to say when we can't do something, I can't do it. I can't do it. I'm not capable of doing this today. I was proud, one of our pilots, he was going to fly offshore at a yacht. And he didn't go offshore to the yacht. And I don't see him on a routine basis. I don't fly that much anymore. But when he saw me, he said, hey, I thought of you the other day and I turned down the flight. All he had to do was fly 2 miles offshore to this yacht. But they didn't have floats on the ship and they didn't have life preservers. So he said, hey, somebody go get us some life jackets. By the time the person got him and came back, Dave's like, you know what? We've all sensed this, right? When you're flying, you feel like you're okay. But as soon as you stop, then you start to feel tired. And he's like, you know what? I'm too tired to go now. And of course, the people were very upset. Well, what do you mean? We just went and got you these life jackets. You're telling us now you won't go? And he's like, yeah, that's what I'm telling you. Good for him. And I told him that. I made a big deal about it. That's how you stop accidents. Could he go out there and fly? Probably, but maybe not. You wouldn't go to your brain surgeon and say, hey, you know what, dude? I know you're not feeling very well, and I know you had a rough night and your kids kept you up, but I demand you do surgery today. If the surgeon said he's not feeling good enough to do surgery, you wouldn't demand it. Why do we demand pilots do things like that? Or why do we even place that expectation on them? And body language has a lot to do with this as well. I do several presentations. I'll speak to medical crew members, and I say, listen, you have a lot to do with the behavior of that pilot. And some of it you're aware of and some of it you're not. But if as a pilot, if I turn down a flight, if you're standing in the doorway of my pilot quarters and I turn down the flight and here's what you do, you go and walk away, what did you just say to me? Did you say, good job, Bruce, I'm glad you're taking care of me and being safe? No, you're like, right? People do that all the time. People do that all the time. They don't recognize it. So the next time that flight comes in, do you think I'm more likely to say, well, shoot, she's going to be irked. Okay, fine, I'll take it. Yeah. And then I go pile the ship into a hill somewhere, and everyone's like, another problem in our industry, I can't believe he did that. That guy had so much experience. How could he make that error? None of us are immune from error. None of us. And understanding our foibles does not indemnify us from falling victim to them. Does not. So, good point, TC. We're building aircraft, the industry, that are fantastically capable. And there are a lot of great organizations that are taking advantage of those capabilities. There are some that aren't. And, we need to do a better job of training people. And that's why if you look at my title, it's not Director of Aviation Training, it's Education. I was fortunate enough, Airbus has treated me very well. I'm fortunate in my life in that I wrote my own job description and I kind of do my own thing. And that's super. I'm happy, Airbus, and I think it's effective. But I make a discrimination between education and training. Training is teaching somebody how to use something, how to work on the helicopter, how to fly the helicopter. I'm not really so interested in that. I am. But what I'm interested in is education, the mind. So think about this discrimination. Education is to training what information is to knowledge. Think about today, every one of us has a smartphone in this room. There is more information available to a human today than ever in the history of mankind. All that information is there. We have more the curve for information is virtually straight up. The problem is the knowledge curve might be the inverse of that. Knowledge is the ability to use the information. Right? If you have a lot of information but you don't have the knowledge to use it, It's merely interesting. So that's what I focus on is education, trying to help us be cognizant of our limitations, know that we're human beings. All of us have a limitation. You know, you can ask someone to go out, and I can ask you to go run a 10-minute mile, and you'll say, well, okay, shoot, I can do that. I can run a 10-minute mile. Everyone in this room can run a 10-minute mile if I asked you to and you wanted to. A few can run a 9, a few less can run an 8, a few less can run a 7. There might be someone in here who can run a 6. It isn't me. But if I asked you to run a 4, you wouldn't even try because you know you can't. Your mind has the same limitations. But we don't recognize that. Think about this. Your mind, your brain consumes 20% of your total energy, net calories in a day is consumed by your brain. Your brain consumes 20% of your energy, maybe 21% actually. And if I asked you to go run a marathon tomorrow, you'd make sure you were well energized to run that marathon. But if I ask you to take a check ride, do you think anyone says, well, I better eat a proper breakfast so I'll be able to think well for a check ride? But you do. And how many people have you, including yourself, ever said to someone, I'm not going to stop for breakfast, or I'm not going to stop for lunch, I'm going to keep flying. I didn't have any lunch today, I just flew through lunch. You know what? If you flew through lunch, shame on you. You should be ashamed to say you did that. You should be ashamed to say you did that. How would you like for the physician doing surgery on you not to have the mental capacity to do a good job? Because that's what you're really doing. And then you're bragging about it. Don't do that. Don't do that. You need to eat. You need to feed the machine. You know, at Airbus, it's in our ops manual. It's in our ops manual. So anyway, I could talk for hours about that. So thank you all. I really do appreciate your attention and enjoy the show. Bye-bye.